friends, how are you? I hope you are doing good. So friends, let us assume in future you become a team leader or the manager of a company and there is a project in your hand, but the dead end is coming very fast. But there is huge amount of work to be completed. What will you do? You will hire more number of workers to complete the same work in the less time. That is, as the number of workers are increasing, the time for doing the project is decreasing. Here, the work is inversely proportional to number of workers. That is, as the number of workers are increasing, work to be completed in time will be decreasing and vice versa. So, in today's chapter, that is variation, let us see the examples of inverse variation and also let us see time, work, speed. If A varies inversely as B, then complete the following table. In the first, A value is 6 and B value is 20 and AB is equals to 120. But here in the second column, if you see A is equals to 12 and AB is equals to 120, what will be the value of B? Yes, value of B will be 10. And in the third column, the value of A is 15. The value of B is not given, but value of AB is always constant. We know that, right? Yes. So the value of AB will be again 120. So what will be the answer here? Yes, the value of B will be 8. And if you go to the other column, the last column, here only B value is given. We know AB value is 120. So what is the value of A? Yes, the value of A is 30. So here that is how you have to calculate the constants. F is inversely proportional to D square. When D is equals to 5, F is equals to 18. Now let us find the value of F when D is equals to 10 and let us find the value of D when F is equals to 15. Now we know F is inversely proportional to D square. That implies F into D square is equals to K. Now D value is 5 and F value is 18. From this we find K. K is equals to F into D square. F value is 18 and D square is 25. Therefore, K is equals to 18 into 25, that is equals to 450. That is the constant of variation here. Now, let us see the value of F when D is equals to 10. Now, we know F into D square is equals to 450. That is a constant. Now, D square is 100. F into 100 is equals to 450. Let us take one example. 15 women finish work of harvesting a groundnut crop in 8 days. Find the number of women if the same job is to be completed in 6 days. So let us see the solution. The number of days required to finish a job is inversely proportional to the number of women employed, right? So let us say the number of days be D and the number of women be N. Now we know D is inversely proportional to N. That implies D into N is equals to constant, that is K. If N is equals to 15, then D is equals to 8. That is given in the problem. But they are asking to solve the question the number of women required when the same work is to be done in 6 days. For that, let us first find the constant. So friends, when you know these concepts of proportionality, either direct or inverse, you will be ready for realistic examples and realistic situations in your life, so that you can be more confident. So in today's session, we have discussed examples of inverse variation and time, work, speed concept with some examples. Before ending the session, let me ask you a couple of questions. Here is your question number 1. If A is inversely proportional to B, which of the following statement is correct? Here are your options. Option A, option B, option C and option D. Yes, you are correct. That is A into B is equals to K is the correct equation. That is option A. Friends, I hope you learned the concepts very clearly, that is directly proportional and inversely proportional concepts, and also the time, speed and work concepts. Thank you. See you soon.